The FASTLIST is a class, or better said a struct. I made it to be able to deal with changes in an array while iterating over it. Imagine an array that we are iterating over. Each time we check for a condition, and if the condition is true, that item should be removed. The normal way of doing this would be to use a list, since a list contains containers that store the pointer to the next and the previous container. If an item gets removed, the pointer to the container before the removed container simply gets pointed to the container after the removed container. But what if I want access to, let's say, container 240? It would be really hard to get there, since the list points to the first container, the first to the second, and so on. If you use a vector, we will get direct access to each element at the cost of moving all containers after the removed container one place to the left. Now that we know the problem, how do we solve it? Well, the solution is actually pretty easy. If a container gets removed, we don't directly remove it. First, we'll tag other containers to be removed too. In order to do that, we store an array of booleans as big as the old size and fill it with trues. But we only want to store an array with booleans if indeed an item will get removed on the next update. To summarize, when an item gets removed from the array, first is checked if there is a mask already. If there is no mask yet, it will be created. Then the aligning entry of the mask will be changed to false. At last, the new size variable will decrease by 1. Sometimes it's necessary to add items to a list too, because we can't remove items that don't exist. For this we use the already existing vector, which is great at storing easy, accessible information in chunks. When an item is added, we don't add it directly, but add it to the vector that stores every item that gets added, and of course increase the new size by 1. When the list updates, we first make a new list. The size of that list is the new size variable. Then we iterate over the old and new list simultaneously. Each time we encounter an item that's deleted, we don't copy it to the new list, but just let it be there. The old list iterator will still increase by 1, but the new list iterator won't. Then we just copy the added members to the list and update all variables. That's basically how the list works. I am out, goodbye.